Again, Brad Taylor. First I wanted to thank Serene and Abby and everybody else. I'm really happy that we were able to sponsor this today. We actually have a number of people here in the back and around. I'm actually at the end for the Q&A going to call down a couple of people who work on the day-to-day implementation of what we do. And I think that will be helpful for the Q&A process. The clicker? There it is. I'll walk right past it. Okay. So I'm going to do some population sampling here, and I'd like your guys' participation, and I'd also like you to pay attention to the responses, because I think it will help you as we go through this. These are not embarrassing questions, but I think the context will help you with what we're presenting here. So how many people here have a commute that is approximately, whether you take the train or drive or whatever, is approximately 100 miles a week? That you drive, train, whatever, 100 miles a week. It's got a few people here, 100 miles or more. Okay, good. Lucky you if you don't go that far. Okay, and then just to kind of get an idea on the automotive side, how many of you have cars that are Wi-Fi enabled, either because you did something to it or you bought it that way? Okay, so we've got a handful of people. And as a corollate to that, how many of you guys are geeky enough or have an advanced enough car that you either have, you use something like usage-based insurance where you plug into the onboard diagnostic port, or you're just like to see what your car is doing, or you have done something else that basically gives you capabilities in your car, like adaptive cruise control or advanced safety systems. Okay, so this is a pretty small number. So I'm going to start off with sort of some background on what we are. So Omnitracs as a company, we are actually Qualcomm's original founding business, and what we do is fleet orchestration. So if you drive by one of these cars, these trucks in your car, there's basically rough numbers, a 1 in 2 chance that we are managing communications for that vehicle. And it's a multi-decade business that predates the word IoT, but we manage over 1 million assets. And the majority of our business is in the Americas, but our routing and navigation business also includes Europe as well. So it's a very significant business with a lot of data, and I think that's an important context to understand when we talk about data and IoT together. We're a really good example of how that all comes together. And what I'm going to do is take you through this concept of how we got to the point where we started looking at value and how that drove both our business decisions and some of our technology decisions, and I think this is going to tie beautifully into Sai's presentation. I don't think it could have been planned any better. So when we talk about big data, a lot of time we talk about the 4 Bs. And big data, has gone from a relatively simple definition. I mean, you guys and I worked for it and said, hey, we want you to come in and build a data lake. They don't do big data. And it's obviously a little more nuanced than that now. But strictly looking at the 4 Bs, we have 1 million assets on the road, of which about almost 500,000 of them are large trucks. Their utilization rate is very high. The average truck driver drives 125,000 miles a year. So if you were commuting 100 miles a week, you're doing about 5,200 miles a week. So that's a lot. The trucks themselves, the utilization is even higher than the driver. So a typical truck is driven more than 150,000 miles a year. So these are assets that are on the road all the time, and they are essentially big gateways at this point. A lot of people think of Teslas as being the most automated vehicle, but in fact, we were connecting trucks over 2 decades ago. And we were using satellite and cellular, and the trucks also enable Wi-Fi for a host of devices and communications for advanced safety systems on the truck as well. So there's a lot of data that we're getting. And of course, trucks are mobile, so we're getting location data and speed vector and other information as well. Because of the dynamics of the industry and the trucks are always moving and customer needs change and deliveries get rerouted, there is a tremendous amount of velocity in terms of the data is not only flying quickly, but it's changing rapidly. And then the variety of data, because we're supporting or a gateway for so many things, whether it's the actual truck OEMs, or for a variety of communications coming from the driver, who's a very important and much analyzed component of what we do. We get a lot of different data types, video now being the biggest one with the most challenges that's coming into play. And because we're also managing a lot of different data sources, veracity is always an issue. You have to figure out what the consistencies are. In some cases, we don't even have a common taxonomy if we're managing it. So the data itself, the raw data, we kind of know if the integrity is right, but if the values underneath there, we may not know. So these are the things that we were looking at from the 4B perspective. But what about the value perspective? Right? So this is, I work for a company that's P&L. We're very EBITDA driven. I get to hear that every week from the CEO. So how did we make decisions on value that helped us move forward with our business? So I'm giving you a little context on, over 1 million assets, kind of what we do for a living, orchestrating all these fleets. And, that's from the individual truck up to coordinated, mechanisms of the universe. And the trucks themselves, 90%, over 90% of the goods that arrive at your house or in the grocery store spend some time on a truck. So it's very important from an economics perspective as well. As a result, we see a lot of different types of information. So how do we go through and determine what's the valuable information and how we should go to market with that? Is it really big data? Are we talking about fast data or maybe smart data? And I'll define that, how we define that as we go along. But if you walked into my office when I first got to Omnitracs in 2016, you walked in there, I'm looking at the release board, and we have a lot of smart people, so we spend a lot of time looking at release boards and trying to think what we're going to do. This is what you would have seen on my wall as I was trying to make a value determination. I needed a framework. And so for us, we kind of broke it down this way. This is something for us, because we're dealing with IoT data, on the relevancy side, IoT data is fundamentally like a lot of data. It's time series driven. So timing is important for us. If you have a dynamic environment, if the data is too late, it's no longer relevant. Location was important. If you think about it, trucks are on the move. They're changing locations. If you're going 60 miles an hour, a minute later, you're a mile away. That location may not be relevant anymore. Obviously, most people don't think about trucks. I'm sure most people here are not really ever worried about it. So you look at information that's very specific to the domain and figure out how I monetize that. And you also may take that domain information, find out how it's relevant in a larger ecosystem. And that's part of what we do from a value perspective. And then entropy. Again, this is more of a function of time, but in a very dynamic environment, where you're talking about a network effect when you've got multiple trucks, the data can go bad very quickly. Now, the other place that we drove value was looking at uniqueness. And so when I looked at enrich, aggregated, and unitary, let me break this down a little bit more. So unitary is that one value that you get in that one piece of data, right? That you get a variable in that one piece that tells you something that is absolutely unique and valuable about that instance. So the ignition is not working on a truck. If you know that piece, it's not going to start, as an example. So a unitary value like that, very valuable. It has a high amount of value. There's also value, that's sort of on the quality end with the unitary capability. The quantity is also important, right? The Russians used to have a saying, quantity is its own quality. If you have enough data, you'll find enough good data to use effectively. And large volumes of data themselves can be useful to someone else besides you if there's enough of it and it matches what their needs are. And then finally, availability. And we'll talk about this a little more, but one, you have to go get the data, and two, you have to be allowed to use the data. And that is also very important, as we'll see. So how do we use these as a guideline to begin to come forward with a plan both for our architecture and our business? So the first thing is, it all starts with legal. I've probably spent as much time with the lawyers as I have with the architecture. And it's an ongoing process. I'm about to bring in some contract help to go through contracts to make sure that we've correctly interpreted all the terms. Because, as an example, we have a lot of large customers in the retail business, traditional brick and mortar retail. They may not want their data being hosted on AWS. I don't know why that is, but that seems to be a problem. So, in addition to that, your data may, in individual cases, have person identifying information, or it may be customer information, that there may be contractual restrictions, or regulatory restrictions as well. We deal in a highly regulatory-driven environment, which is both positive and negative. So the impact on the business. I picked this logo specifically because it does seem that sometimes money makes the world go round in my world. Certainly if it's not a not-for-profit and They're examining what you're doing and how you're spending your money. That's a factor. And so time to market, I think size, talked a little bit about, what are you trying to do and when do you have to start showing revenue growth or some kind of risk reduction. So that's a real factor in your decision-making process. And your communication with your management may be driven by this as well. I can tell you that while I hear the term data lake a lot from my management, hey, we're building a data lake, because that's the term they recognize. If I built the data lake, it would not meet their expectations for time to market, ROI, and return on cash. All right, so the other thing, and this is starting where you look at your data, and you look at the value of the data what you have, and we, generically have for a long time used the term big data. But big data really isn't just big data anymore. It's fast data, and it may be smart data. And so when you're looking at the value of your data and trying to determine a strategy, it's helpful to understand what you really have. Because that may influence what you do from a business perspective, as Sai kind of talked about, and it may also influence your architecture. And yes, there is an architecture slide in here. So finally, having looked at these things, what do you do from an architecture plan? And how does that drive the value? That's an important part because if you're building a data lake and you're going to fill everything up, and you're a company like Omnitracs who has a foundational company, but also has some acquisitions, you have a number of silos you have to deal with. And it may be that a plan to build a data lake won't actually fulfill your needs from an architectural perspective, at least not in the time frame that your management will keep required. So, what did we do? Well, in the case of Omnitracs, we actually had taken the 3 use cases for big, fast, and smart and done a little bit of each. And the order is very specific. And it is both an architectural decision, a business decision, and a non-architectural decision, and I'll explain why. So the first thing is, we started looking at how we can make our data smarter for our predictive analytics. We had an existing predictive analytics business. It's relatively small, but it's for some of the largest food customers in the world. So we're typically talking about 15 or 20,000 vehicles at some of our larger customers. And the focus is very much on one of the most fragile components of the whole transportation system, and that is the driver. And the drivers are incredibly important because, one, you've got a lot of regulatory responsibility. In order to avoid accidents, they have amounts of time they can drive. You want to avoid driving certain hours that may cause fatigue. There's a lot of aspects that you can help with on that. The second thing is they're a critical point from getting the truck from point A to point B, at least for the time being, and there are not enough drivers to serve all the loads right now. And turnover is very high. It runs high as 75% in a year. So for our predictive analytics, what we would do is go in and take a series of data sets and then focus on whatever the outcome is we're looking to prevent, whether it's quit, an accident, and obviously better data in a transitional environment, what we're having in the fleet world, which is undergoing a lot of change, is very important. But there's also a cost driver associated with this as well. So we traditionally had done this by going to a large customer and saying, give us a bunch of different data sets, a bunch of stacks of hay. And we will put those together. We'll create integration on your custom data sets. We'll order those fields and values and put them away that we can begin to access them and begin to look at those existing predictors that are there, and then try to determine, which predictors you want to use, which have the highest reliability. So this is a fairly expensive process because you're talking about, in some cases, at least half the data we deal with is at the customer side. And so we do what we call these custom models. And there's some problems in the prediction process with this as well. One example might be if you have similar predictors from different data sets, with values that may change or not exactly aligned with the taxonomy is not the same. It's often harder to get a good model without a lot of work, and in some cases you can have an overfitting problem. So what we began looking at is we want better quality data, what we're calling smart data. And we want it to be as high value as possible, as clean as possible. Well, in a regulatory environment, the good news is that there's a financial incentive for a lot of the participants to make sure the data is of high quality, otherwise they get fined. So we've changed our focus to being from a lot of different data sets from a lot of different sources to a smaller set of data sets, some that are tied to regulatory environments so they know they're relatively standardized and consistent, and other ones that are actually under our control. So we can turn out a model more efficiently, understand the ROI, and better articulate the value to our customers as well as improve our time to market. And it didn't require any architecture changes at all. It just requires us to think differently about what we're doing. Now, on the new monetization front, my management always talks about the data lake, except that's not what we're doing because the data lake is data at rest. And in a dynamic business, data in motion is much more important. So just what we call speed vector data, which is off all those trucks, where they are on the freeway, how fast they're going in that direction, is well over 100 billion data points a year. That's before we pull anything else. Not talking about fuel tank levels, not talking about wearing the tires, not talking about anything about hard braking, anything coming off the adaptive cruise control. That is strictly the data points for the location. Well, it's interesting. I'm sure everybody here at one point is using nav at this point. And if you have, almost 500,000 assets on the road every day in the form of trucks, you have a lot of data relating to what the speed is on a given stretch of road. And so we're able to actually anonymize this data and turn around and sell it. So the requirements around this from a relevance group perspective are fairly interesting because it really doesn't help you as a consumer of traffic data. If you find out that the data you have is 5 minutes out of date, it doesn't reflect the road segment. So we have to deliver this within 2 minutes. So that implies a different architecture than a data lake. And because this is pretty significant value to us, this will be several millions of dollars going forward for us starting this year. We went ahead and emphasized this in our architectural build-out. You'll also know you see things like blacklisting, encryption. That's the legal aspect of what we do. This not only serves our external customers in an anonymized format, but we have internal customers that this data is incredibly critical to. And one of the gentlemen will be here and joining us in the QA. Trucks are a little bit of a different beast. If you think about a large semi, it's not going to drive the same places that your car goes. It's got problems with height, it's got problems with width, it has problems with weight. It also may be restricted by regulatory guidelines on where it can drive. Hazardous cargoes can't drive in certain places. When you drive along the freeway, you may see trucks are restricted from certain lanes. So it's important we understand the parameters and where we're going with the truck, because otherwise we can easily lead the truck into a location where there is a problem. So in addition to the one-to-many relationship my management cares about, which is the monetization of dollars, how many customers can I get and how much money do they get for those customers? There's also an internal consumer for this in our routing and navigation. And we have to ensure that the navigation and the routing are coordinated, because if not, it causes problems for the fleets. And we're going to talk a little bit more about the implication of this from a future perspective. But right now we have a very nice routing business, an up-and-coming nav business, and basically it's a part of not only what we do now, but what we're thinking about as we go forward. But this basically was the first architectural decision for us, is while we talk about data lake, what we built is a fast data architecture that actually looks more like something in Twitter or Facebook. So now we come to the big data part. Hey, still trying to do the data lake. And we've made some decisions on data. Obviously, we have a much broader perspective of data. Top of that corner, this is about 50% of an enumeration of the data sets we have available. So how do we use that as we go through and build out the quote-unquote data lake process? So, as the quote says, the truck industry is going through a lot of changes right now. Uberization, automation, continuing driver shortages. It's obviously a volatile industry. There are a lot of things going on. Amazon is having a big influence right now of the fleets as well. And so we're going in and looking at what's happening. So I asked a question earlier about if we had adaptive cruise control, or advanced safety systems or something like that in the car. That's a relatively new phenomenon in vehicles that you would, by almost default for an automobile, be able to go in and get an advanced safety system. Fleets are very similar, except there's a little bit more investment in it because the payout for an accident is very high. So they make those investments because they avoid these unexpected dips to their bottom line. What we found looking at the data as we started to aggregate it was that a lot of our predictive models had been based on the assumption that hard braking, overspeeds, really basic functionality was very predictive and was representative of important data trends. But when we did the analysis this year, what we found is that our fleets, about 15% or so, maybe 17%, in that range, had advanced safety systems. So they had lane keeping, they had distance following, just an adaptive control, the things that you would need in an advanced safety system. Stability control, because trucks tip over. That 15% of fleets was generating 90% of the what we call critical events, which is the notifications that something bad is happening. And there are mandates coming down in the truck space. If you buy a new truck starting in 2018, it's got to have certain safety systems on it. So we know, looking at that we're about to see a deluge of data even substantially larger than we have right now. So we have to start planning with that. So that's one way that the big data initiative is helping us tell the future. We're also using predictive analytics to come back in and look at this data. And has anybody ever heard of the Hawthorne effect? So the Hawthorne effect is if you're under observation, do you change your behaviors? So if you're told through gamification or through monitoring, say by a video in a vehicle, that your driving is not correct, will you change your behavior? Will you begin to drive slower? Will you begin to drive safer? Will you do less dramatic lane changes? So we're also using our data to begin to look at, do we get a positive Hawthorne effect off things like video if it's facing in the cab? So then again, this helps us to understand what's happening with the drivers, and it'll help us make better decisions on what kind of products we release and the value to the fleets. So coming to the right here, because I'm going to go clockwise since we're talking about the future. I talked a little about the routing business that we have. And of course, if you go beyond just 1 year to several years, we're talking about several hundred billions of data points. And so we get a pretty good idea over a multi-year period of where the trucks are going. Part of the reason we have people here, including Monty, who will join us later, is we're going back and looking at that data. And Julius, if you're out there, I haven't seen you, come on down at the end of the presentation. We're going back and looking at all these data points. And we're starting to go through it, because we have very sophisticated capability for mapping. So we can look at a road arc and then map points to that road arc based on what we get from our speed vector data. We can take these hundreds of billions and billions of data points over several years and start to map them into what we call the truck preferred network. It's not only important to know where you're allowed to go, it's also important to the drivers to know where the best place is to go. And so we're starting to use that data to make those determinations. Now, if we go clockwise a little forward, you'll see the navigation here. And again, we've talked about supplying data to the traffic providers who do navigation for cars, but we are obviously creating truck-specific navigation itself. That navigation, and this is some of the work that Bonnie is working on as well, and as architect, he's done a lot of the architecture for the navigation team and its integration and routing. We're looking at that because that's a dynamic relationship. The planning is done with the routing before your day starts. And they take the entire fleet and figure out how they ought to go. But things happen along the way in the course of the day. Customer changes in their mind. You run into weather problems. There's road conditions because the road's icy. And so we have to be able to take that route, balance what's happening for the individual driver with the navigation, feed that back into the route management for the fleet orchestration, and do it in a way where we manage all these various events, whether they're weather, business, or what else. Again, that's a big part of the problem that we run into. Julius, why don't you come on down the front here? I'm about to actually ask you to come in anyway. So So that's an important part, and again, this is what both Monty and Julius have been working on, is putting these pieces together in a way that's very coherent, and that requires both an understanding of analytics and also of architecture. So then finally, this last piece down here with the percentages. Are any going to be frightened when cars or trucks don't have drivers? Well, you're kind of lying about it. Even working with it, I get a little nervous about it. And the good news is this is not a brand new evolution. This started in the 90s with LiDAR and a lot of the work that was done at Carnegie Mellon and other places. So it's coming very quickly, and we're going to have an important role in that. And so one of the first things that you'll see, what this slide represents, is what they call platooning of trucks. And platooning of trucks actually will still have a driver in the vehicle, but it uses automation to coordinate multiple trucks together so they can create common following distances and create efficiencies of economics using that capability. And this week we actually announced a partnership with a company called Peloton, which is the leader in truck platooning. Now, where our team played its role, both from an analysis perspective and then from what we're doing to facilitate that, is when we were assessing what we were going to do from a partnership perspective, we were looking at the ROI for our large fleets. Schneider, if you've ever seen a big orange truck, Schneider's a big customer. What are the Schneiders of the world, when's their ROI going to come from fleet platooning? And what we found was that if we did the analysis based on the current cost of equipment, that it was very difficult, even for a large fleet like Schneider, to see an ROI in less than 5 to 7 years with only intra-fleet platooning, meaning only their trucks. But if we got to the point where we could quickly move to inter-fleet platooning, the value is returned much quicker. The ROI is there. And so the same architecture that Monty and Julius and everybody have been putting together for location-based architecture for routing and nav is sort of the first step in what I usually call truck dating. So if you're trying to get your trucks together so they can platoon together, but you're from different companies, you have to have the tender for trucks. I'm not trademarked that, maybe I should. And so we're actually playing a leading role of that because we already have this data on all these trucks that are going across the United States, and we understand the routing from the truck for network that these guys are doing right now. So in a sense, while our value has been driven by first predictive analytics because it didn't require any architecture investment, we just wanted to get better data because better data beats smarter algorithms every day. Second, time to market and monetization. Again, my manager uses the term data lake. I think fast data because I knew that when we put this together, we looked at our value proposition, that that's where we can get to market quickly and with data in a new market, so it would be additive to the bottom line. And then finally, using what I would think is more traditional big data, we're going into all this really rich resources of data we have and starting to tease out trends in the industry that maybe we didn't realize without looking at the data. So that's how we've gone through that value proposition, turned that into sort of a strategy and then into architecture. And so with that, I'd like to invite Julius and Monty up here, since they actually do the work and I just sit up here and look pretty, to help with the questions on the Q&A. And if you gentlemen, if you just give a brief description of what you guys do on a day-to-day basis so the audience can get a feel for that.
So I'm Julius Flanagan. I work for Brad. I'm a data modeler / data scientist. So pretty much I do predictive analytics from visualization to data munging to how does that actually affect return on investment. In the last month, I've started working on navigation. I don't want to steal Manus' thunder, so I'll let him explain that.
I'm Mani. I'm a system engineer and system architect working for navigation, which is the product that we brought to market last year, specifically focusing on the trucks navigation. I'm focused more on the data integration to make our navigation much better than any of the products in the market.
And would you also, Julius, give a little background on the tool sets we use internally?
So when I joined Omnitracs, we we're using SPSS modeler. Since I joined, we started using HAL. With navigation, we've used Python, we've used Spark, Scholar, just all the big data tools you can imagine. Kafka, Flume.
Yeah, Kafka is the messaging platform you're using. I think many of the people are asking the question on what are the languages that I need to learn to be here in this data platform. The basic is Java, followed by what we are using is messaging platform. We're using Kafka. For data storage, we're using HBase and Redis. For data load, we're using Flume and many of the Hardenworks products. And for services, we are using Java to write REST APIs. And when we want advanced service orchestration, we use TIBCO's BusinessWorks and Oracle Server Suite platforms. So it's a variety of tools. We choose it based on the needs and based on where is the original data stored and how we want to distribute it. But the fundamental is Java. If you know Java, everything is done.
And just to add a little bit to that, part of the project we're working on right now, we've got pretty much around 14 billion records, which are position data of all trucks across the nation. Being able to then snap that onto something like an interstate, trying to find out where exactly the nearest interstate, and then using that to be able to determine which interstates are frequent, mostly driven by truck drivers. It's something, I don't know if anyone else is doing it.
So why don't we open it for questions? It's really got a minute left, and you can always find these guys later now that I've identified them. And I'll show you their picture if you want to talk to them later. Go ahead.
What other types of data would you plan on using to try and generate more value? Like, for example, you were showing on one of the slides the type of data, like vehicle data, operational data.
Great, good question. So we have a division that actually does load brokering, 1 million loads a year. We've not even touched that yet. Load brokering. So
Load doesn't forces them?
it loads as in I have a priced out load, but I don't have a truck to ship it in. So it's a monetization transaction, and we've not even touched that. We have some very basic reporting on that stuff.
And what's your plan to work with companies that are getting into the self-driving? Are you working with companies like that?
Well, the first partnership that we've announced, obviously was this week with Peloton. We actually were in discussions with Otto before they got bought by Uber. So we've been doing this a little bit, and then of course, at some level, all the safety equipment OEMs that we're involved with, Bendix and other guys, are going to play in this in some way. And so Bendix is an example. Any safety equipment they put into a truck, we bring the data back for them because we're the data gateway for those guys.
Sort of related to that, when the driver is paid at least for a long distance part of the trip, how does that affect your business?
I don't think it's going to be a big problem. It'll hurt the predictive analytics business a little bit, but we don't see that happening. And there's already a driver shortage, which is why part of our business is on retention of drivers.
So what I'm interested in is what kind of data are you guys gathering from the drivers themselves to make your maybe things smarter?
We've got critical events, lane violations, overspeeds. We've got also personal information, not personal information, but information relating to their how much money, the variation, and how much money they're making.
One more question, maybe? Oh, all the way in the back.
You mentioned earlier about selling this data.
Mhm.
Can you speak a little bit about the data points that maybe you can sell and who the recipients would be?
So, I think I'm going to use some people we don't sell to, but it would be typical, so I don't violate any NDAs. So if you think of Google and Apple, they both do maps with traffic on it. We have additional value because not only do we have sort of the generic data on what's happening on the roads, but we even have truck-specific data. And so there's value, and that's coming back to the unique value piece, right? When you have the largest aggregation of trucks on the road by market share, that has value on its own. And so we can tease value both from just the generic anonymization of data for the traffic providers and then specifically there's truck data. Thank you very much.